Hello, my name is Julie Wirtz. I am the Beal Family Postgraduate Fellow in Conservation Science in the Strauss Center for Conservation and Technical Studies at Harvard Art Museums. Today I'm excited to talk with you about cyanotypes and how to make them. Cyanotype is a printing process that yields a blue image. One familiar use of cyanotypes is architectural blueprints. The word cyan comes from the ancient Greek word for blue. A cyanotype is made by exposing the prepared ground, typically paper, to ultraviolet light. Direct sunlight is ideal. Unlike black and white silver colloid printing, which is sensitive to white light and must be prepared in a dark room, cyanotypes can be safely prepared out of direct light. They are also developed using only water, which is easily obtained and less complicated than the silver colloid developing process. The sensitivity of cyanotypes toward ultraviolet light rather than white light makes it more suitable for direct printing or photograms. If the cyanotype paper is not in direct contact with the negative when exposed to the sun, the image will be blurry. This means scaling an image for printing, like with photographic enlargement, is not easily done. On the other hand, large objects can be reproduced quickly without specialist equipment, making it ideal for objects like blueprints. The cyanotype process was invented in 1842 by the English polymath John Herschel, who also made advances in photography. In 1843, Anna Atkins, a pioneering British botanist and friend of Herschel, published the book British Algae, Cyanotype Impressions, which is considered to be the first commercially published book illustrated with photo images. You can view a copy online through the New York Public Library's digital collections. This cyanotype from our collection is a 1909 print of a photograph taken from Forest Hills Station by Paul Rohl. Its dimensions are about 9.5 inches by 7.5 inches, and it was probably printed directly from a glass plate negative the same size as the image. This cyanotype is a 1913 architectural blueprint from Standard Buildings Incorporated, based in New York City, for an affordable duplex home. A transparency of this design would be prepared and used to make copies for distribution. It is about 16 inches wide and 12 inches high. This cyanotype is a work by the contemporary artist Sheila Pepe with a black ink design added on top. It is about 15 inches wide and 22 inches high. These works illustrate the versatility of cyanotype as a technique. The pigment that gives cyanotypes their color is called Prussian blue, or ferric ferrocyanide. Prussian blue was invented unintentionally in the early 18th century by a Swiss dye and pigment maker named Johann Diesbach, who was preparing a red pigment when he used a reagent contaminated with blood, causing a blue material to form instead. This example is in the Forbes pigment collection at the Strauss. Prussian blue can be prepared a few different ways. Here, the cyanotype process depends on the presence of ferric ammonium citrate and potassium ferrocyanide. The chemical formulas are shown beneath the names and the structures are shown above. The iron in ferric ammonium citrate carries a charge of +3. It forms a crystal structure with the ammonium, highlighted here, and the citrate, highlighted here. This molecule also forms the basis for citric acid. The ammonium and citrate are not integral to the cyanotype and are washed away in the developing process. Potassium, highlighted here, forms a complex with the ferrocyanide group. The ferrocyanide structure, highlighted here, shows 6 cyanogroups with the carbon triple bonded to the nitrogen, all attached to the central iron atom. This iron also has a charge of +3. The presence of cyanogroups, which also form the basis for cyanide poison, may be concerning, but cyanotype making is completely safe because they are always tightly bound with the iron. The triple bonds exchange electrons, which contributes to the blue color of the pigment. Cyanotype paper is prepared by mixing ferric ammonium citrate and potassium ferrocyanide in water, then applying it to the surface and allowing it to dry. When exposed to UV light, the iron citrate bond is affected, resulting in iron with a +2 charge rather than a +3. This is able to form a complex with the ferrocyanide. Washing the print removes the ammonium, potassium, and citrate and allows the Prussian blue complex to take on water, or hydrate. As it reacts with the environment, it oxidizes or takes on oxygen, allowing the color to develop. The structure of Prussian blue is complicated and variable depending on how it was made, so it is difficult to represent with a crystalline structure. It is generally fast to light, although technical studies have shown under certain conditions it is susceptible to fading. A thoroughly washed cyanotype should be fairly stable to light exposure, and faded cyanotypes may be rehabilitated by a period of storage in a dark, slightly humid environment. Today I am going to demonstrate how to prepare cyanotypes from the dry chemicals we discussed. I purchased them pre-weighed as a kit from a photography supplier for mixing with water to make stock solutions. The chemicals are reasonably safe to use, but please remember to take precautions against spills, dust inhalation, or accidental ingestion. You can also purchase the solutions pre-made for mixing or cyanotype paper ready for exposure. This is likely to come in a light-proof bag, possibly with a clear plate for exposure. And as you'll see, this paper is actually blue, whereas the paper we're going to be making is yellow. So I think they've put something in as a visual indicator to help you understand when it's exposed. This paper is also fairly small, but you can buy all sorts of different sizes from art and photography suppliers. You can find a lot of useful materials around the house. I use a cut-up cardboard box for an absorbent, disposable surface to prepare cyanotypes on. It's also good practice to keep your chemicals in separate containers for measuring, so I use just empty containers from the recycling or this disposable medicine cup for measuring my stock solutions. It's helpful to have a foam brush for spreading out your sensitizer on the paper because the bristles might end up leaving a pattern in the pigment. For my exposures, I use a piece of glass from a cheap picture frame that I put some tape on the edges for, and I don't think that this has a UV coating, which might interfere with the process. You can rinse your prints in almost anything, the sink if you want. I've got this plastic tray, or you could use any sort of waterproof container. And if you're preparing a lot of paper at once, you're going to want to make sure to have somewhere to store it that's light-proof. So I use this file folder, and then I made a black envelope to go into. You can also get some kind of heavy black bag just to make sure it's protected. Here is 40 grams of potassium ferrocyanide, which is a crystalline powder with a rust-like color. This will be dissolved in 500 milliliters of water. Here is 100 grams of ferric ammonium citrate, which contains the UV-sensitive bond. It is in a light-proof bag to help avoid exposure. This will also be dissolved in 500 milliliters of water. And it looks like this, a greenish-yellow crystalline powder. The stock solution should be stored in an opaque bottle and away from light. I only have transparent bottles, so I'll store them in a box. The stock solutions will keep for a while, but the mixture does not. So it's best to prepare only the amount you need at one time. You should mix equal parts by volume of the stock solution to make the sensitizer. I made these at double concentration because I didn't have larger bottles, so I also have to add a second volume of water. This container has 10 milliliters of water in it, and I will add 5 milliliters each of the stock solutions. This solution is potassium ferrocyanide. And this is the ferric ammonium citrate. I'm working with slightly more light than is ideal for these compounds, so I can show you in the video. But you don't need to be operating in the dark either. And as you mix those together, you get a kind of greenish-yellow solution. The paper can be sensitized in low light, so you can see your work. The paper I've chosen is a 300 grams per square meter paper, which is about 3 times heavier than your typical office paper. The paper you use should have some weight to it so it doesn't get distorted while wet. Prussian blue is sensitive to alkaline or high pH environments, so some buffered papers may affect the stability of the print. I'm using a foam brush to apply the mixed sensitizer to the paper. It should be brushed from multiple directions to ensure an even coating. This is a fairly smooth paper. Highly textured papers may have a more visible grain or coat less evenly. It's best to layer the sensitizer slowly to avoid pools and streaks on the dry paper. You should avoid touching the paper once sensitized because you might leave marks on the print. If you work without gloves, remember to wash your hands afterward. I had some light blue stains on my fingers that faded after a few days. The sensitized paper, now yellow, will be laid flat in a dark place to dry. I'm going to demonstrate printing a negative image on the paper I prepared and a positive image on the commercial paper for comparison. You can also see the different colors and that this is yellowy green and this is blue. For the negative print, my positive image is a leaf cluster picked from the back garden. The positive print will be made with this negative, which I have taped to the glass plate. The negative should be underneath the glass with the paper for optimal sharpness. The paper is lightly affixed to the glass with the sensitive side up. The leaf cluster can be placed directly on the sensitive paper and held in place with the glass. Then everything can be covered again with a light-proof cover until it's ready for exposure. If you're not sure for how long to expose your plate, a test strip can help. Cut a length of cyanotype paper and expose it in set increments. This time-lapsed video shows 75 seconds of exposure in 5-second intervals. My cyanotypes were fully exposed after around 2 minutes of direct sunlight. This time-lapse video shows the 2-minute exposure of the plates I prepared. On the left, the yellow changes to blue, while on the right, the blue becomes lighter. Here are the exposed, undeveloped prints. You can see in the commercial paper that the original blue is water sensitive. Rinse your cyanotypes for about 5 minutes in a light flow of cold water to permanently fix them. Then let them dry flat, under weight if necessary. Here are the dry, developed prints. The blue on the paper I prepared is not as dark as the blue on the commercial paper, so I probably could have applied a few more layers of sensitizer to get more contrast. The grain of the paper is also more pronounced here, indicating I didn't coat it evenly. The weight of the heavier paper means almost no distortion has occurred, whereas the lighter paper has crinkled. It probably would have been best to dry this under weight. One other major difference is that in the commercial paper, the white isn't actually white, more of a light blue, which you can see when I contrast them. It is not clear whether this paper has aged, been exposed, or maybe this is residual indicator, as you noticed in the washing process. This print was made by drawing on this plate with a permanent marker, and I added more sensitizer to the paper. The marker did not completely block the light in all the areas, so it kind of looks as though it was drawn in white on a blue surface. And again, you can see the grain there of the paper. You can try printing various objects, drawing with different materials on the plate, cutting stencils, or even painting with the sensitizer to make a monotype. Cyanotypes are an easy and fun way to experiment with printing, and you can make a lot from one kit. As always, when working with chemicals, it's important to follow directions and not experiment without consulting a qualified source to ensure your safety. I hope you enjoyed learning about cyanotypes, and thanks for watching.